Well, hello everyone. My name is Matt Chiotti, and thank you for joining us for today's session. This is going to be, I think, an awesome session. We've got some pretty awesome experts on the stream today. So, welcome everyone. We know you're joining from multiple different platforms, so we're super excited to have such a far reach on this. So today we're going to be talking about some of the latest findings from Palo Alto Networks and Bridgecrew's Unit 42 Cloud Threat Report. We'll get into a little bit more detail on that in a couple minutes, but let's just let everybody say hello so you can know who you are listening to and why you should listen to what they're saying. So why don't we start just a brief intro, like 30 seconds, guys, right? I'll start with Matt Johnson. Why don't you give a quick intro?
Yeah. Hey, thanks, Matt. It wouldn't be right to not have two Matts on every call, right? So,
Requirement.
hey, I'm Matt Johnson. I'm a developer advocate with Bridgecrew. Passionate about cloud infrastructure security, cloud kind of pen testing, and all things codified security in general. I've been playing with containers and cloud infrastructure since Sun Microsystems had Solaris zones. So I've bashed my head against the security tree a few times, you could say. But yeah, super excited to get into this report.
Awesome. Q, why don't you introduce yourself?
All right, awesome. Yeah, thanks, Matt. And Matt, it's awesome. Two Matts. I've never been on a call with two Matts before. So, all right, yeah. So I'm Nathaniel Quist. I go by the letter Q, first letter of my last name. That could be James Bond or Star Trek. I prefer Star Trek, but James Bond's pretty awesome, especially the new one's just out. It's amazing. Go watch it.
I haven't seen it yet.
It's pretty good. Yeah, so I'm a senior threat researcher with Unit 42 and Prisma Cloud. So it's kind of like bringing the intel into the cloud and trying to extrapolate who's doing what, when, and where. It's kind of my passion, my hobby. So.
Awesome. Jay, we'll let you finish it out. Tell us who you are and maybe what you're passionate about.
Sure. Thanks, Matt. My name's Jay, and I am a security researcher with Prisma Cloud and Unit 42. I'm passionate about cloud native technology, and I love to try out new tech, break new tech, and find how people use new tech in security. And my research has covered container security, container orchestration platform security, and public cloud security.
It's awesome. Well, this is going to be great. So I think we've got a pretty interesting cast of characters here. So I didn't actually introduce myself. I'm the Chief Security Officer of Cloud here at Palo Alto Networks. And what we're going to be talking about over the next, 45, 50 minutes, we'll see, is, again, our latest cloud threat research. And you can go to that link at the bottom of your screen there. Just go to cloudthreat.report. And yes, that is an actual URL. It is totally valid. Cloudthreat.report. And that will take you to the latest cloud threat research, which we will be talking about a little bit today. So I think it's always important to say this. So anytime you look at anything that claims to be threat research, I always tell people, like, don't read anything until you go to the methodology section and find out, like, how do they actually carry out that research. So everything that you're going to hear about is not based upon surveys. We didn't ask anybody, like, what do you think? Like, surveys are useful, but they tell you what people intend to do. They don't tell you what they actually put into practice. So everything you see here is collected from live sources, and it's actually really fresh. So it's just of July of this year. So download the full report, and we'll cover a couple things from that here. So I think, before we get into some of the specifics of the report, I want to do just maybe a quick round robin of the team here, just to really kind of get a sense of maybe what you found most interesting in the report. So I will start with Dr. Jay Chen. See, he doesn't ever tell anybody that he's a doctor. He's a PhD. If I had a PhD, I would be like, my name is Dr. Matt. So Dr. Jay Chen, will you tell us, what did you find most interesting or maybe most surprising about the data in this report?
Thank you again, Matt. And so what I found most surprised and interesting in this research is to realize the complexity and dependencies in our modern software supply chain. And the cloud native application that we use and interact daily is pretty much the tip of an iceberg. Like, there are so many dependent components that support what we use daily that typically we don't see. And those dependencies can potentially cause security issues in the future. And that's my biggest surprise, or my biggest most things. That's the thing that surprised me the most. How the complexity below it.
That's pretty cool. Yeah, we're going to show in a minute here. We're going to walk everybody through. You probably hear this theme over and over of just complexity, and so we have a slide we'll walk you guys through in a couple minutes that I think will illustrate just how complex cloud native architectures can be. But Matt Johnson, what about you? What really stood out in the data of this report?
Oh, it was definitely the complexity. No, just kidding. It still is. It ties to that though. So. Yeah, for me, it was the fact that, we regularly talk to customers who are like, oh, but what about this complex scenario? And what about this like brand new emerging threat? And what about X, Y, Z? For me, it was just the fact that a lot of the CVEs in a lot of the images that are being used across kind of multiple different people's infrastructure, you still have CVEs in there back from like 2016. Let's not be focused on what is the newest, most interesting emerging threat. Let's just kind of patch our images.
I love it. Q, how about from your perspective? I know that I think you said this a little bit in your intros, but you come from a kind of an intel background, right? So with the U.S. military. So I'm curious, what stood out to you in this?
Yeah, I mean, without jumping on the bagman with the C word right there, everybody's been
the complexity.
Is that what it is? Complexity? I think this is a complex topic. No. Or cloud. I mean, but I think the biggest thing that I found interesting was it's just organization, right? I mean, with complexity, it's how do you organize it? Is it organized? Is it not organized? And if you can properly organize it, I mean, we can stem a lot of these issues from the very beginning if we just get into the how it's made, where it's created from, where the data is being pulled from. And actually looking at the code itself and then organizing it in a way that's manageable and easy. I think that's the biggest one. Y'all threw me for a loop. It's a good thing I had two bullet points there. Otherwise, I'd be like, oh yeah, complexities are the most amazing thing.
He's like, I can't talk about that one now. So Q, I know that we obviously even in an hour we don't have time to cover everything that's in this report. I think the report's like 17 pages. I forget. I'm sure there's a couple filler pages in there somewhere, but it is a solid in-depth report. Encourage everyone, again, go out and download the full report. But Q, maybe you can give us just maybe a minute or two on, there was a red team exercise that we carried out as part of this. And I think those are always fascinating because you can look at statistics, which we will talk about, but when you do the hands-on, like what can you actually accomplish? What can you get into from a systems perspective? Maybe just kind of set the context, like what was the red team exercise? What did they ask us to do? And, try to sum that up in a couple minutes. Curious to hear. Tell us about that red team exercise.
Yeah, I'll make it short and sweet. So the red team exercise, we posed as insider threats. So we already had limited access to an environment. And who we were targeting was a large SaaS provider. It's our SaaS vendor, provide tools for a lot of different organizations, downstream clients, things of that nature. And what we try to do is we try to model our red team exercise after some of those really famous supply chain attacks that we've seen recently. Just name drop like SolarWinds, Kaseya, things like that. And we wanted to figure out how did they actually do that? What did they target? Maybe why did they target that specific thing? So we kind of modeled our red team event after that. What are the pieces that we would target? And those pieces that we would target would be those repositories or those containers that are shipped out that would be put into a client environment that would then give us access to downstream clients. Just SolarWinds itself had some 18,000 downstream clients that were affected by it. It's a very large and frightening number, where SolarWinds wasn't even the primary target. I mean, they were the target, but the primary target was who was in the back end of all that. So we kind of tried to develop around that. So what we what we found is means we already had kind of limited access to that environment. We had developer rights. We wanted to see if we could gain cloud administrative rights to that system, which would allow us to be able to get into that data repository from those developers and then be able to modify code inside of that. So long story short, we did get cloud administrative access into that system. We used a relatively common technique. It's called pass role, IAM pass role inside of the AWS infrastructure. And then we were able to gain, essentially make an EC2 instance that had a specific role that allowed us to get administrative rights, which means we could control the rest of that cloud environment. How we found that really was interesting because that was the primary issue, is that as a developer, we had full unmitigated rights to all data repository inside of that developer account. So we were able to get over 150 different repositories. And inside of those data repositories, we were able to find 26 unique AWS access IDs and their keys and some service tokens. And then to spread across over 50 different AWS accounts. So it's really pretty amazing that just with one access, we were able to access everything. And it was all about role-based access control, or RBAC, if you want to call it that. And that was like the root cause. The secondary issue is only one of those AWS accounts was actually being monitored by GuardDuty and also subsequently fed into a tool like Prisma Cloud that did enable a detection. So we were actually sort of caught by one of those accounts. But again, there's still 49 other accounts that we were able to maintain access in and propagate the attack. So yeah, some caught, some things were caught, but we still had a lot of unmitigated access to the rest of that cloud environment.
So, okay, so if I understand the kind of the setup, so you're approached by a customer, they want us to red team. This wasn't an outside in style attack. This is sounds like more of an inside up. So poses a malicious insider. Okay, so that's cool.
Yeah,
so
exactly. I mean, and we kind of like circumvent, because we only had a limited amount of time really in order to scope some of this stuff. I mean, if you were, say, like APT29 or something like that did attack SolarWinds, then they started with a phishing attack. They were able to mitigate into the access into this particular developer account, and then from there they could go and do what we did. We just kind of jumped to square Z first, or I guess W or whatever. So
cool. All right, so that makes sense. All right, so we cover that obviously in a lot more detail in the report. So you get the message here. Download the report. You'll get all that detail that's in there. I think what would be really cool would be is if we just kind of paint the picture for the audience around we keep using the word complexity, but let's just give that a picture. So when we say that cloud native supply chains are very complex, let me just show you what that means. So generally speaking, when we're talking about cloud native architectures, they are usually built in 3 distinct phases. And so what I want to walk you through, and then definitely for JQ and Matt, I want to get your feedback on this as we go through this, because you're going to see there's multiple of different issues that are gonna pop up as we go through this, and we'll illustrate this. The other thing to remember, and I think, Jay, you pointed this out in the research, is that even a great architecture can inherit many misconfigurations and vulnerabilities from all of the dependent packages. So let's look at what this looks like, right? So there's usually 3 phases. Step 1 is the cloud infrastructure provisioning, right? So you've got to build that base infrastructure. The second piece of it has to do with, typically in a cloud native environment, usually it's some kind of Kubernetes application deployment. And then finally, you have the part where you actually launch the containers. In this first phase here that you're looking at on your screen, there are, in this case here, the developers have chosen to use, they're using Terraform, and there are really 3 main modules. There's a VPC module for networking, there's Kubernetes, and then there's storage. Now, the storage module, this is where you're going to start to see this complexity build. The storage module also depends on 2 other modules. So if you're not that familiar with when we're saying modules, just think of this like Legos, right? So I've got a Lego, I've got to add on to it, and you've got all these different Legos that make up this application. So if you're keeping track of the numbers here, right? So after all 5 of the modules are deployed, well, now we have a total of 9 misconfigurations that have been introduced. And this is just in just the basic cloud infrastructure provisioning. We haven't even gone on to the next two phases yet. So with the third phase, now we're at the Kubernetes layer. So what we often see is that, Helm charts are an extremely popular way to deploy Kubernetes applications. And that's what Helm charts are, just like a package manager for Kubernetes. And in this case here, we have another series of dependencies. Okay, so you've got a main Helm chart that depends on then two other Helm charts. And then each of those Helm charts depends on two container images. Okay, you can see this web of complexity starting to just absolutely grow. And so after all three of the Helm charts are deployed, well, now you've got a total of 5 Kubernetes misconfigurations that are introduced. So we've got the 9 in the cloud infrastructure layer and 5 new ones that have been introduced in the Kubernetes layer. And guess what? There's still more. There's still another layer, right? So we've got this, the what I would call the final layer of the cake, which is now, well, let's deploy the actual containers. Okay, so each container image is instantiated, and it goes to one or more of the containers in the cluster. And then inside each of the containers, this is where the application code and all of its dependent packages are loaded into memory. Okay, so in this case here, we've got about 8 different containers that are running the actual application. And guess what? And we'll talk about this a little bit in detail in a couple minutes when we show you some of the statistics. You now have 40 application vulnerabilities that are introduced as part of the application itself. So if you do the math, you've got 40 vulnerabilities that live in the container images or in the application itself. You've got 5 misconfigurations that are at the Kubernetes layer and 9 misconfigurations that are in that base infrastructure layer. So Jay, I got a question for you. I know that you did a lot of research as part of this, kind of around just some of the complexities around getting visibility into these different dependent packages and dependencies. I guess what stands out to you here? Like, what are your thoughts? How do you kind of see this?
So you think this is complex? That's not the end of story. Guess what? We have more. So we may have 40 vulnerabilities and 14 misconfiguration here, but the chain of dependency doesn't stop here. So we stop the graph at the application, vulnerable application, but think about how we build containers, how dependent libraries and package are packaged into the container. Typically, when you build the containers, you use package managers to install operating system dependent libraries or platform dependent libraries. For example, if you build, if your container image is based on Debian, you may use APK, not APK, APT or DPKG to install your dependent libraries, and that library is created and packaged by the package managers, which usually are not the developers of the source code. So if you want the latest and greatest open source tool, you sometimes need to build from the scratch. You sometimes need to pull the source code, build it yourself, and put it into the container. But this is not the most cloud native way and easiest way to maintain your application. So here you depend on like package managers, and same as for the platform dependent libraries. Like if you are building the Python application, then you usually use pip to pull your Python dependent libraries. If you are building a JavaScript web application, you usually use npm to pull your dependent library. So again, there are more dependencies on this supply chain. And guess what? This is again a overly simplified architecture. in reality, in the production environment, you usually have more than one application, and each application has its own infrastructure. So you can have multiple infrastructure just look like this, and more misconfiguration and more vulnerabilities. And finally, let me talk about people. So developers, like at the end of the day, developer is the one who write the code, and developer humans are the one who make mistake, who create the bugs. And think about it, how many people that we need to depend on, we need to trust for standing up this infrastructure, right? Each each Terraform or infrastructure as a whole package is maintained by a set of people, and each Helm chart again is maintained by a group of developer, and each operating system libraries or application library again maintained by a different group of developers. And I think we can, I don't know the number, but we can easily depend on more than thousands of developers for this simple infrastructure. And what if any of the developers' laptop is compromised? And what if any developers become nation state hackers? So yeah, I think I can spend an hour talking about this, but that's really what I try to explain. Hey, in reality, the problem is even much bigger than this graph.
I appreciate that feedback. There's a lot to this, and it's, I'd be curious from, either Q or Matt. I mean, based upon what you've seen in your experience, I mean, we say that this is as complex as this looks, this is actually fairly, as Jay mentioned, this is fairly simple, right? I mean,
yeah, I happy to weigh in on this with two sides of the story. Like, yeah, every single one of those three boxes is the tip of an iceberg. But at the same time, the developer advocate in me wants to be like, but like we are not trying to scare people with this. This is just a fact. The report has the data to prove it. Luckily, we can say that we know there were 9 misconfigs and 5 + 9 and 40 + 5 + 9, because we have tools that you can easily put in your pipelines to give yourself this visibility and this information. So, knowing this is a solved problem. But yeah, equally to add to what Jay said, with complexity, and the kind of hidden bits in each of these boxes. Let's not forget that this isn't what most people would class as, cloud native architecture. The people writing cloud native architecture are caring about, well, okay, like, what is my API endpoint to get my customer data to this other service? What, S3 or RDS instance am I connecting to make sure that these two pieces of business logic tie together? Everything that we're talking about here is just kind of the crap you have to do in the background, pardon my, expletives, to make that business logic be somewhere in production in the first place. So a lot of the time you're going to be grabbing these components from who cares where, because it's not the point of your sprint. It's not the point of your business product. It's just stuff that has to happen. It's like boilerplate. And so, it's very easy to kind of overlook a lot of these like underneath architectural components.
Yeah, if I could just weigh in right there. I mean, the complexity, obviously is that, but I mean, how do you run back to the beginning? And I think cloud infrastructure, just in and of itself, I mean, we are still, I think, in the phase of really just getting things up and running. How can we make it up and running? Remember, when we're all on-prem all the time with data centers and stuff like that, it's like we want to have 99.9999% uptime, and that's the most important thing. Security, go away. It's kind of like the same thing with cloud in some aspects. It's kind of like we have all these applications and we need to get these services up and running and available and ready, no downtime ever. But the cool thing about cloud is that the security can like almost literally be built in after the fact that the application is up and running, because we have this very modular, dynamic, running and going. You can build that scanning, that shifting left of security into the beginning of your pipeline before, even after this thing is built. You'd be like, oh, I have an issue right here. Let's just insert security at the beginning, and then it just has a trickle effect into the rest of your cloud chain. And it's very important to know, like, yeah, we can have these things, but there are tools, there is visibility that we can put into that chain, and then we can, sort some of these things out before they get too much farther down the road.
I love that point. And I know somebody just asked the question, yeah, but how do you do all this at scale? It's easy to say, especially when you're on a webinar. And we will answer your question as we get a little bit further into the data. But I think anecdotally, again, we'll kind of cover this, I think, at the end here. But I think to answer your question around, how do you do this all at scale? Well, in our view, it is not something that a security team per se should be trying to do themselves at scale. You can't hire enough developers, enough security members rather, to do that. I've been in organizations where, they've tried to say, look, with every development team, we're going to embed, N number of security members. It doesn't work, right? I think there's some research that we did previously, and I forget the exact number. I might be off a little bit by a bit, but I think IaC squared says there's roughly, I think it's like 1.9 or 2.4 million security professionals around the world. And the CNCF said that I think there's just over like 4.3 million cloud native developers. So there's just you can't automatically go out and find 2 million new security people and have a one-on-one. You can't do that. So the only way that you can do it is by enabling developers with cloud native security tools, right? So that's the only way you can do it. Now, Matt, I know that you spend a lot of time in your role, right? I mean, the whole thing with DevRel is exactly that. Like, what have you seen work at scale? I mean, we can answer this question now. We don't have to wait.
Yeah, 100%. And that is the key, right? Like, I know that the term DevSecOps is just such an overloaded buzzword, like every other buzzword. But the idea that you can have kind of speed ups by having dev and ops working together to own that infrastructure, through automation, through, saving time, like saving minutes a day, just automating little things like bits of your pipeline, like testing, like deployment to production. But the idea that you would be able to do any of that and then not include security as another automated part of that pipeline, if you have the best DevOps pipeline in the world, but you're still waiting on a manual out of pipeline loop through a security team to go and, look at your new containers, to look at your new Helm packages, ignoring the fact that most of them are going to be dynamically generated as part of your build pipeline anyway, it's just not going to scale to the point. You're never going to throw enough people at this to do what you're trying to achieve. And sadly, those people are going to leave really soon if you tried, because that is not a fun life, just waiting on, GitLab to go, well, I've done what I can in my CI pipeline, but now I need you to go and poke some manual buttons. So yeah, like using open source tools, treating security just like you would treat tests in any other part of your application infrastructure. And also the fact that we're in a good position for that, because we've never had a more descriptive set of APIs for what we actually need. Back when we were on-prem, I couldn't define exactly how I needed, Sarah or Bob to go and build that server and install Linux and configure TFTP and blah, blah, blah. Whereas with cloud APIs, I can. With Kubernetes manifests, I can. With Helm charts, I can. So we're actually in a much better position to have these tools be able to automate against these data sets, because we have schemas we can actually kind of run those tools against. So yeah, automated tooling is key. I'm sure we'll share a few open source tool suggestions by the time we finish this session. But yeah, it's 100% an automation thing rather than a people thing, I'd say.
So that hopefully that answers your question. I know that you can't just again go out and hire 100 different security engineers, and nor should you do that. That would be, quite frankly, an inefficient use of resources, given the plethora of tools that are out there, like Bridgecrew, Chekhov. That's one that we obviously love and highly encourage people to use. We'll talk probably a little bit more about that later. So if you do have questions, feel free to drop them in the chat. We will try to answer those as we kind of go through this. Plus, if you throw us a curveball, it always makes it a little bit more fun than if you ask us softball questions. So the harder the questions, the more fun we have. So, all right. So keep those questions coming. All right. So let's pivot a little bit here and look at some of the statistical research that the team did. And we're going to look at a couple different components specifically. These are probably the three most popular components when we look at open source or rather cloud native applications. So we're going to talk a little bit about what we saw from our research around Terraform templates, Helm charts, and then container images. And we'll kind of go through those in that order. So just to give you a little bit of context and just background around how we did this research. So our researchers used Bridgecrew's Chekhov, that's Checkov, like Star Trek, Chekhov. You can go out, you can download that now from our GitHub repo. And they use that to analyze literally thousands of Terraform templates from popular open source repositories. And remember, the owners of any of these, they could be a cloud service provider, it could be a vendor, it could be an open source developer, it could be a ATP, right? Or an APT. So it could be any one of those things. Let's look at some of these, and then I want to get feedback from the rest of you guys here on the call. So here's what we found at a high level, right? Number one is when we looked through this just massive number of templates, and the sample size was huge. We didn't just look at like 100 or like 1,000 templates. We're talking tens of thousands of templates. We found that almost half of them had at least one critical or high severity misconfiguration, right? So just looking at that base layer. And I think, Matt, I'd be curious to kind of get your thoughts on this to see if my hunch here is accurate. Is it accurate to say that most developers are not writing their Terraform templates from scratch? Are they usually pulling them from these like public repos? Like, can I correctly assume that they're starting from one of these popular registries like a Terraform registry or something like that?
Yeah, 100%. Code reuse in infrastructure as code is alive and well, just like the millions of Node modules you might download if you try and use a Node application. I think if you were writing your own, you're still going to have the same issue that the original authors of the reusable components have, which is, a working Helm manifest might look like this. A working Terraform module might look like this. A secure Terraform module for doing the same thing won't fit on the page. And, we always go back to that security versus usability. What's easiest for people to grok? What's easiest for people to kind of get up and running with for hello world really simply? And it's usually that simplicity that makes it go further and further through the pipeline and eventually end up somewhere in prod.
Yeah, that's what I thought. I thought my hunch was correct there. It's been a while since I've done any development, so good to hear that it's still that same way. Now, I know that one of the time when I showed the 49% statistics, a lot of times I get questions and they just say, well, there could be a lot of garbage out there. Well, we narrowed it down and we said, what are the most popular downloads, right? What are the most popular download modules? Well, when we look at those, the numbers actually get worse. 64% of those resulted in at least one high or critical insecure configuration. So, Jay, I know that you did, I think, a good bit of work around crunching some of these numbers and looking at it. I guess the question here is maybe when you look at, we're looking at kind of the probably the most high level part of this data set. Were there specific misconfigurations that stood out when you looked at this 49 or the 64%?
Right. So the number of on Terra from the repository, we can see how many times that each of these templates or modules were downloaded, and the number of downloads sort of indicate the popularity of this module and how many users have used these modules. And the more downloads, the more times that these modules have been replicated. And in terms of the misconfiguration that we saw across templates in different cloud service providers. I think one interesting finding is that these misconfigurations are sort of CSP, cloud service provider agnostic. Like people make the same insecure configuration no matter where they are in AWS, GCP, or Azure. And the most commonly seen misconfiguration were expose sensitive service to the public internet, such as RDP and or SSH service. And the second most seen misconfiguration was unencrypt data at rest. Like when you create a database or create a cloud storage, in some cloud service providers, these data are not encrypted by default. And I mean, the best practice is to always have your data at rest encrypted. Right? And the third commonly seen misconfiguration was insufficient logging. So again, by default, logins are not enabled for most of the cloud resources that you created, because when enabling the login, usually there are some additional cost. And I guess CSP doesn't want you to feel that, hey, doesn't want you to give to cost you more to create a new service or resource. However, without enabling logging, you really don't have the visibility. You don't know what's going wrong in of your cloud native application, and if something goes wrong, you have nothing. You have no trace to do forensic, and you cannot do audit. So this is just super important to have logging enabled.
Jay, one of the things you mentioned was just, there's commonality between when we look at these misconfigurations that are coming from these Terraform templates, infrastructure as code templates as well. I know we looked at some other things during the report. You mentioned exposed services, right? SSH, RDP, Q. I think from your perspective, I think we talked about this in a previous report when we talked about common exploits. RDP has its issues. Why is that? Obviously it's kind of a worse practice to expose something like an RDP or an SSH to the internet. What are the type of threats we're seeing in terms of how threat actors, specifically in the cloud, are able to leverage those types of exposed services? What does that look like from a threat perspective?
Well, sure. Actually, I'm going to ping off of one of Jay's other researches, kind of a follow on with the CTR here, was that if you look at the number of exposed systems that are out there and how fast they are targeted, as soon as they come out. I mean, Jay did an awesome blog on honeypots just recently that some honeypots were actually compromised within minutes of it actually being stood up in the first place. So there are certainly mitigation aspects that you can put into that. But I mean, if you have like an SSH that is highly targeted just to begin with, as soon as that service stands up, within minutes you will have somebody poking at that door trying to get in. If you're not taking things like doing SSH keys or your RSA keys, authentication inside of that, and that's both SSH and RDP. If you're not doing some sort of encryption, authentication check on those services, they're just going to run rampant with that. Just look at exploit DB or something like that. And you'll see that there are a number of different open SSH, depending on what version you're using on that particular system, a number of vulnerabilities just, right for the taking if someone's, just using default configurations or default system, settings for those particular systems. But I think a lot of this, if I can just segue just real fast, if we go from like a SOC perspective, if you're a person, analyst behind the keyboard looking at alerts and stuff as they're, trickling by, and the amount of logging that is required in order to, perform that identification and create that rule, and then actually perform an alert on it in the first place. And then you look at the amount of the volume of data that the cloud can just, completely vomit at you. It's just, it's overwhelming when it comes to, the tools can be there, but in order to get some of that logging in, you need to have, like a big query or something like that in order to parse all of that data, so rapidly and so quickly. And again, a lot of this kind of goes back to, building that secure template securely to begin with, knowing where your data came from, knowing, scanning it to begin with to see if there's any of these, issues, and if we do that in a cloud perspective, from a cloud side, we can use that dynamic nature of cloud and just to be able to roll that one image out thousands of times, and it just, we can kind of catch that before it even really becomes a problem later down the road.
I love that. Let's look at it from a Helm charts perspective. We did some research here specifically around Helm charts. In this case here, we again looked at a large data set, right? So we looked at over 3,000 Helm charts and nearly 9,000 YAML files that were in Artifact Hub using Helm Scanner. Again, Helm is just a Kubernetes deployment tool for automating the packaging and deployment of apps and services to Kubernetes clusters. So to look at the data, right, I'll just pop both these up on the screen here. Again, you can see the numbers are not, let's just say, to be kind, let's just say they're not favorable. Almost all of them contain one or more insecure configurations. And this is an interesting one. When we look at where those misconfigurations come from, 62% come from the dependent charts. 62%. So, Matt, maybe from your perspective, Helm wasn't, to be honest, if I'm completely honest, before we did this report, I wasn't familiar with Helm. How popular is that? And where does it kind of fit into this whole ecosystem?
Yeah, I think if you're consuming someone else's Kubernetes manifest, realistically, up until now, you've been using Helm. It's really the only option until kind of Kustomize came on the scene, which is making headway. And again, I wouldn't say that don't use Helm charts. I wouldn't say that code reuse is bad. Again, it just goes back to that kind of usability versus security thing that we kind of see with Terraform and kind of other code reuse as well.
Okay. So I know one of the other things we looked at was just to kind of, I think, expand a little bit on correlations to this. There was a direct relationship between the number of dependencies and the number of misconfigurations. And I think this was also consistent in the container area, which we'll talk about in a minute. When you looked at, and I think Jay or Matt, either one of you guys, feel free to comment on this. When you look at some of the most common and maybe concerning misconfigurations we saw around these, what are maybe just one or two things that stood out in the data, and then we'll jump over to container images so we can keep everybody on track for their schedule. Jay, maybe we'll start with you.
So the most common misconfiguration in this Helm chart that we analyzed are overly privileged capabilities or permission granted to the container users. And most of the application don't need to run as a root, and most of the container doesn't need to run with privilege permission. When you have a privilege permission, you essentially share the host kernel, and basically you can access the device on the kernel, and if there's any vulnerabilities that you can directly gain control through the host. So I mean, there are some legit use case for running the application using privilege permission, but most of the time privilege permission is not required. And these are the most critical misconfiguration that we saw.
And is it the fact that you're seeing so much overly permissioned access? Is that just most likely because it's the easiest way to deploy something, right? If you give it full permissions, you don't have to deal with dealing with permissions. Is that likely why we're seeing this? Because I know we've seen this in other research we've done as well.
Right. I didn't look into each individual application to see, hey, if this is a legit use case. Like another another issue is the capabilities. Docker by default block most of the Linux capability, but sometimes for some specific purpose, like you need to send raw packet in your container, you need network role capability. But I guess some of the application that used to run in on-prem infrastructure were lift and shift to container. And the easiest way to make it run is to give as many permissions as possible.
So that makes sense.
I can jump in with a little bit of insight from my experience as well on that. It also goes back to a lot of the time I find that securing these things in Kubernetes manifests and therefore in Helm templates, because they're effectively one and the same, requires adding extra stuff to the manifest. If you don't know to add that extra stuff, you are just going to not have those security additions by default almost. And there's a blog post my colleague Steve wrote actually where he took kind of the default Nginx manifest, which was about 12 lines, and added all the items to kind of make it pass all the Kubernetes CIS 1.6 benchmarks. And it ended up being like 50 lines. So, if you are new to writing Kubernetes or Helm and you don't know to add those specific things, or you don't have something in your CI/CD pipeline telling you to add those specific things, or you haven't consumed page by page and got, your tongue full of printer ink, the CIS guidelines recently, what are the chances you're ever going to know to add those things to a Helm manifest?
That makes sense. So it's like Kubernetes as a technology has really not been around that long. It's been a number of years, but it's not been that long. So there's also the component of just the people side of it, right? Of not knowing. And then there's those that are just not knowing and also not having the right tools to fill them in to the, to provide those details around that. So I think one of the other pieces that goes hand in hand with this is when we look at containers, right? So containers are a critical part of any cloud native application. In this case here, our researchers looked at container images that were used in those Helm charts that we talked about. And we looked at over 1,500 distinct images that were studied. And we pulled these from public registries like Docker Hub, Quay, Google Container Registries. And I think what I'd love to kind of dig in a little bit here is I'll show the statistics. You can see that they are they're not good. Anytime you see a statistic this high on a security chart, it's not usually a good thing. We found that virtually all of the container images that we studied have some type of known vulnerability. Like known vulnerability. That means there's an existing CVE for it. We're not talking about like a 0-day. And if you filter that down to just, hey, I don't care about informational or kind of low priority vulnerabilities, and you just look at critical or high severity, 91% of them have a high or a critical vulnerability. So I guess the question I put out there to the group is what is it that is driving these numbers to be so high? Because I know we've done similar research, and these numbers are they don't seem to be trending down, right? So I'll just kind of throw that out to the group. How do you guys see this?
I'll just jump in just real fast. Having worked as in SOC and looking at compliance and coverage and vulnerability assessments and things of that nature of data centers and now into cloud. Application vulnerabilities are a thing. Just go look at ExploitDB and just find out how many different applications there are that have vulnerabilities that are publicly known and exploitable. It's a very big thing. I don't think it's necessarily so much the container itself being vulnerable. That's going to happen. Somebody's going to poke a hole into an application. How do you secure it? Is it secured behind is that mitigated? Do you have a firewall in front of it? Do you have applications that are preventing that sort of access? And again, within a cloud environment, you have VPCs, you have your different kinds of systems and monitoring that go through there. You can have service mesh frameworks that will actually segment your cloud network faster and faster. And more refined, so you actually limit that access. So again, knowing your vulnerabilities is key. Organize your SOC, organize your security. Know what systems you have out there, know what vulnerabilities you have, and then make sure that you have mitigations to cover those.
So I think we saw the same pattern when we looked at just the dependencies, right? So if we look at, for example, the number of dependent packages, there was a direct correlation with the number of vulnerabilities. Jay Chen, I'm curious, why are these why are these not getting updated? Like, what's your thesis on this? What are you seeing from your research?
Again, I think this is not this should not be a surprising correlation. If we assume there's on average 5 vulnerabilities in each containers, and the more in each application package, and the more application package that you rely on, then the more overall vulnerabilities will be seen in your system. And I think one thing I want to share is that modern, again, it's go back to our dependency issue. Like modern software rely a lot on the third-party code, and what we have seen since I think 2000, like early 2000, is that because software components are highly modularized and reusable, it's so easy for you to import a library just for one of its function. And what we are seeing now is bigger and fatter application being deployed quickly, because you can easily import so many third-party components. Your application can be developed much quicker, but it also become bigger and fatter. And one research that I did a few years ago is that I checked how many of the packaged dependent libraries are actually used in a container runtime. And what I found out is like 80% of the files and libraries can be deleted, removed without impacting the actual functionalities of the container. Like in reality, when people use a container, they only use a very small subset of the function, and most of the files or libraries packaged inside the containers are not used, and they can be safely removed. And when you remove those unused, unrelated package, you just remove a lot of vulnerability as well. So yeah, so the bloated software is a big concerns in modern cloud native application.
I think that's a great point. And it's funny how things change, but how they don't change over time. I remember, Matt, I know I saw on your resume that you spent a lot of time back in the day with Solaris systems, and so did I, right? And I remember some of the hardening scripts that we would run on there. And what was it doing? Like, what was it doing? It was turning off all these non-essential services, right?
Uninstalling packages, and for sure. Yeah.
So I know that, Matt, you did some additional research around with Helm Scanner 2.0. Why don't you walk us through this and tell us a little bit about what you found? Oh, you got the mute going there, the mysterious mute button. Still
You're
going.
muted.
He can share a screen. He can unmute himself, but he can only do one at once. There we go. Yeah, when we were going through this data, like I was finding it really, really hard to visualize. And the reason I think was just because there were so many, as you said, like 62% or 59% plus 90x% CVEs. And to me, that was like, okay. And at the same time, we've been having conversations with customers about even just in checkoff outputs on existing kind of code bases. If I enable this for my teams, they are going to have their CI/CD pipelines filled with 500 errors, and nothing's ever going to get passed. Like, what do we do about this? So I started thinking about like, what is like the blast radius of some of these CVEs plus misconfigurations? Like, if we consider them together, does visualizing them help us prioritize and work out kind of what is the noise and what is the signal? And so we've just released a blog post on this called Graphing Misconfigurations. Might be an interesting read. And the concept is, for example, if we have a load balancer that's open to the world, but there are no backend services behind it. So There's nothing to have a CVE because that load balancer goes nowhere. Is that misconfigured? Yes, but is it something we will really care about from a security posture? Potentially not, because there's no access given to an attacker because there's nothing behind that. And so that got us thinking. And so we've created like a POC website that we'd love to get some feedback on called Helm Scanner. And we've taken all the CVE and all the check of policy violations that we're talking about in this report. And we've produced a website where you can actually search for those for each Helm chart and view them in graph format. So we see here that this Helm chart, for example, has these checkoff checks and these CVEs. And if we view the graph, we can actually kind of dynamically look at that and go, okay, well, where in our Helm chart are they? Like, okay, so I can see that this is the image that these CVEs are related to. This image is being used by this daemon set. This daemon set is, has these particular policy issues, and you highlight them and you can see what's going on. And potentially that's just an easier way to visualize how bad something is when you know that you are talking about potentially thousands of issues. Like, for example, would you deploy this image? Personally, I would probably try and dig into this a bit and find something else rather than deploy this. And yeah, we're hoping it just provides a really interesting new way of kind of thinking about CVEs and misconfigurations together, rather than thinking that, the app team has CVEs over here and the infrastructure team has like, misconfigurations over here.
I would totally deploy that though. I mean, totally deploy that in a honeypot and just
do a honeypot.
Let me stop sharing my screen now. Sorry about that.
No worries.
Yeah, just push to production, see what happens.
All right, so we've got about less than 5 minutes left. So we'd love to take some questions in the last 3 to 4 minutes that we have left here. So if you have questions, feel free to ask those, and we will try to answer those here in the next minute or two. I think from my perspective, this has been a really great conversation. And one of the things that we attempt to do in the threat report, which you can download here, you can see the link on your screen. Again, just go to cloudthreat.report, and you can sign up and download the actual full report. Yeah, this thing over. Oh wait, it's this way. It's over here. So you can download the full report. I know from my perspective, this was really kind of eye-opening, and I think for a lot of security executives that I speak to frequently, that chart that's in there that we talk about, like just kind of that multi-layered cake of cloud native development, I think is really eye-opening, and it's led to a lot of really good conversations around how there's what's been really in the news over the last 2-3 years are misconfigurations in the cloud, but it's really been focused on misconfigurations of kind of the cloud layer itself. It's not really gotten into, well, how do we proactively address those types of issues? And obviously we've shared a couple links on the screen to a couple of the tools that we have on the Bridgecrew side that are, I think, extremely helpful and just really serve a great way to empower developers to be able to write infrastructure as code securely from day one. Again, we've talked about kind of the numbers issue side of this. You're never going to be able to hire enough security practitioners to have a one-on-one match, or even probably a 1 to 5 match. The only way you can do that is, again, by arming your developers with cloud native tools like Checkov, Your, and Air IAM, so that they can write code securely from the start. Well, thank you for joining us today, Matt, Q, and Jay. It was awesome having you guys. So thanks very much for joining us. Again, don't forget to download the report and dig a little bit more into our research on infrastructure as code and some of our container security research. And don't forget that you can get started today with Bridgecrew for free. Visit us out at bridgecrew.io. Thank you for joining us.